Hello, I'm Allison. I want to talk about a project that I started working on a while ago. It's called Chromatic. It's something to help kids learn music. This talk's going to be about like everything and nothing. And if I'm saying something and you're wondering what the point is, there probably isn't a point. That's just kind of one of those talks, I guess. So I guess I'm going to start, like, music is here first. Let's start with music. Oh yeah, here's like my unofficial logo, I guess. This is sort of also what the software does. It makes things that look like this. What is a note? Of course, this is a sound, but it's a particular sound. It's a particular frequency of sound in particular. And you can see here, it's a sine wave. This is the simplest sound. This is this like really like that you would hear, like a very simple sound. It would be a lot more interesting looking if it was an actual instrument. What decides the sound of an instrument is how this wave is shaped. But what decides the note is how many times it cycles per second. And of course, we measure that in hertz. But yeah, what is the A note? What is A note? It is defined as 440 hertz. So if somebody's playing A4, like on a piano or any other instrument, that should be 440 cycles per second of sound. The note A was invented in 1975 by the ISO in this beautiful document. They went into a lot of research. It's a whole 3 pages long. And because this is the ISO, you can't actually read it, unfortunately. Yeah, tough luck. I'm sorry. But you can buy it. And if you think that like 43 Swiss franc is maybe a little bit expensive for a 3-page document as a PDF, don't think of it that way. It's actually less than 10 cents per hertz. Of course, if A is 440, you don't just have A 440. You can have like A 1 octave down and A 1 octave up. So this is basically the same note, but in like a different octave. And these are done in 2-to-1 ratios. So if we have A 440, if we go up an octave or down an octave, down 1, you get 220. Up 1, you get 880. And you can say like A3 is the one that's down 1, and A5 is the one that's up 1 from A4. By the way, if you play these two things together, it's not going to work, is it? Okay, so that's A4. And then if I play it together with A5, oh, yes, of course. It's going to do that, isn't it? Because that's also the hotkey for searching. Lovely. Yeah, so that and that, they kind of sound like the same note, right? And this, they're just higher and lower, but you can sort of hear that they're the same. And if you play them together, you can kind of, they sound very, very similar. And they sound good together. And the reason for that is because you can sort of see how these waves line up to each other. You get 1 cycle of the purple wave, let's say that's A4, and inside of that, because it's going at twice the frequency, you get 2 cycles of, let's say it's A5. So much for octaves. That's a really easy relationship to understand, but of course we have other notes in music, right? I'm going to switch over to talking about C here. Sorry for that. I don't know why they specify like the frequency of A as being the standard, and then always talk about music starting from C, but I'm going to switch over to C here. C is, by the way, 261.63 hertz approximately. There's actually like some alternate tunings that define C as equal to 256 hertz, which I think probably is very appealing to a lot of computer people. Unfortunately, that's not the ISO standard, and we don't want to mess with those guys. They're Swiss. Yeah, so this is just the same thing that I showed before, but let's imagine here that we have like the middle C and then the high C is the double frequency one. But then, of course, we can get different ratios. So here's something called the perfect fifth. This is 2 notes that happen to sound really nice together. So if I play C and then I play G, they kind of sound like nice together, right? It's like a nice... This is like maybe one of the nicest sounding things in music. This is how you play power chords on the guitar, by the way, if you want to be like a cool, guitar rocker. Yeah, so these sound really nice together. They're the nicest note pairing other than the octave. And you can see here that they're in the ratio of 3 to 2. So you get 3 vibrations of the screen wave for every 2 of this purple one. And notice how at the beginning and end, they line up really nicely. So like over this duration, they come back in sync, and they keep syncing up with each other. And that's basically the physics of why it sounds so good. Like, that's a physical process, and that's what your ear gets coming into it. And your ear thinks, hey, that sounds nice. In general, the things that sound nice are these ratios with small numbers. So we had 2 to 1, and now we had 3 to 2. This whole process is called just intonation, by the way. This process of building notes relative to a root, in this case C, using these small ratios. So relative to C, the tonic is just a fancy way of like saying the note itself. That's 1 to 1. The octave is double that. The perfect fifth we covered, that's a 3 to 2 ratio. And then if you think of sort of like the other smallest ratios you could think of, 4 to 3 and 5 to 4 come out of there. They all sound relatively good. I can play, so here was that's the fifth, right? And then the fourth. And then the third. And you can kind of already hear that like this, it sounds okay, but it's maybe not as nice as that. And that's a result of the fact that it's a slightly bigger ratio. So it's still small, it kind of fits, but it's not as good as the perfect fifth. It turns out we can decide, OK, let's plot this. This is log scale, by the way, because it's a doubling every octave. So if we want all the octaves to look the same, then we got to do log scale. So here's the notes we were just talking about. C, octave C at the other end. And then there's the fifth is G, F is the fourth, and E is the third. And those are the ratios, again, that we were talking about. The tonic, the octave, and then the ones in between. So those are the ones that sound good. I noticed there's some gaps here. Probably like we could like fill some stuff. Like probably one note fits in there and two notes fit in there. OK, of course, then we fill in D, G, and A. Those have these ratios, which are still kind of smallish, but maybe not as nice. So I mean, like D, yeah, it's like still kind of something that you could play together, but not the best. A is sounding OK. And what was the other one we added? B is also not great. Out of all of those, A is probably the nicest. And again, you can see that with the numbers. 5 to 3 is obviously nicer than 9 to 8 or 15 to 8. And then, of course, what do we do next? These are the white keys on the piano. We can fill in some of those gaps. So you can see like between C and D is an obvious gap to come in. Between D and E is an obvious gap to come in. Not between E and F, which is why there's no black key between E and F. Between F and G, between G and A, between A and B, those are those three black keys. But then between B and C, there's not enough room. So this is basically why the black keys and the white keys are where they are on a piano keyboard. And yeah, you get some of these are like looking OK. This 45 to 32 is like, are you kidding me, right? Like, this is ridiculous. It's diabolical even. I'll get to that in a second. But yeah, it's still, it's good. Everything is like in these nice ratios. But they're sort of irregularly spaced if you look. It's a little bit messy. And that's a problem because if, for example, I play the interval from C to C sharp, that's kind of big in relation to the interval from D sharp to E. So if I were playing a song in C, and then I say, OK, I want to play that song in D sharp, it's not going to sound the same because that interval of going up one note is a lot bigger when I play it in C than in D sharp. So I can tune my piano like this, and as long as I play songs in C major, everything's going to sound really nice. But as soon as I want to go to a different key, I'm going to have to retune my piano. Somebody decided at some point that retuning a piano every time you play a new song was not a practical solution. You could also buy 12 different pianos. That could also solve the problem. But maybe a better engineering-minded solution here is why don't we just fudge it a little, right? Like, what if we just move those around a little bit so that they are lined up? So I started talking about just intonation, where we have these perfect ratios. There's something called equal temperament. And it turns out that if you take these and you say, instead of arbitrarily spacing it, because that's how the ratios work out, you say each note is the 12th root of 2 times the previous note. This gets you really ugly numbers, because now we're in a rational space. As soon as you take roots, you're dealing with irrational numbers. But now, if you look on the log scale, they're all perfectly evenly spaced out, which means that the distance from C to C sharp is the same as the distance from E to F or any other pair of numbers in terms of that multiplicative distance, which results in how the waves line up with each other and how you perceive the music. So this is basically again, an engineering solution for this I don't want to retune my piano every time I want to play a song in a different key. And if you look, they kind of line up not bad. Some of them are really good, like that perfect fifth G, pretty much right on there. The octaves obviously are right on, because that's by the time you multiply by the 12th root of 2 12 times, you get just 2 times. And that's the same in just intonation as well. Everything else is approximate, but it's not too bad. I mentioned that I talk about this, this diabolical note. This is the tritone. It's been called the devil in music since the Middle Ages. And it sounds particularly terrible. It's the combination on the piano keyboard that sounds the worst. And it's everything to do with that ratio. So like if I want to play that again, that would be this. It sounds kind of like diabolical, right? There's like a whole bunch of rumors like in medieval times that you could get like excommunicated from the church if you ever played this note or something like that. It's probably false. I don't know. I wasn't there, but people generally avoid this, if not to be excommunicated, just because it sounds terrible, right? And you can see here that like it just doesn't line up. It doesn't come back to that unity with each other, unless you want to repeat it, whatever the lowest common denominator of 45 and 32 times is. It's just really, really nasty. So yeah, that's kind of like why we have 12 notes here, because this process of doing that lines up nicely. But there's another reason we have 12 notes, and that's called the circle of fifths. And what you can do, that fifth relationship I talked about, 3 to the 2, which is equal to like 1.5 times of something, right? Like 3 over 2 is 1.5. If you follow that, so the perfect fifth of C is G, the perfect fifth of G is D, the perfect fifth of D is A, and so on. And you go all the way around the circle until you get back to almost C. I get to that in a second as well. But this kind of follows, if you think about it, if you're in equal temperament, because you're doing 12 operations of this like root of 2 thing, right? And then the fifth is like the seventh root, the 7 over 12 to the power, 2 to the power of 7 over 12. Anyway, you get over 7 octaves by playing this full circle of fifths. Also, like if you want to play guitar and you're wondering what chords you should put in your song, just pick 3 of them that are beside each other, and that's every pop song ever. But yeah, something happens interesting here. If you follow the circle of fifths using just intonation, so again, following this 1.5 jumps, this perfect ratio, we do it 12 times, you get 128, or 129 to 75 times the original frequency, which is super cool. Like that's really close to 2 to the 7, right? And if you think about that in terms of, we made 12 steps, and after we made 12 steps of compounding an error, we're only out by like 1%. That's actually really cool. This is a super cool coincidence. And this is like another argument for, OK, and on the way we hit all 12 notes. So this is kind of like why we end up with 12 notes. I found this diagram on Wikipedia. This is super cool. And basically, this is like following the circle around the outside as if you were following just intonation. But then if you take these individual steps, those are following equal temperament. And after you take all 12 steps, you're out by 23 cents, which is basically 23 100ths of a half note by the time you finish this whole process. And that's that 1% that you're out by. And I find this stuff like so cool that it's so close after doing that. These 2 numbers that should have nothing to do with each other. Speaking of circles, there is this guy, Isaac Newton. He liked thinking about music too. He drew the circle in 1704. And you start to see that there's a relationship between color and music. In terms of you have, if you think about a color wheel and how you can go around the color wheel, and you get further and further away from red, going through like your yellows and oranges and blues and greens, and then when you follow it all around, you kind of get back to purple, and then you're sort of getting back into red. This is kind of a lot like going around the notes, right? Like you go from C, D, all the way around, and B, you're getting back to C again, and it's the same note. So just like you can go around the color wheel, it's kind of going around this same musical wheel. And yeah, Newton noticed that, and he sort of, yeah, maybe we could propose something like this. Of course, in sort of our modern understanding as computer scientists of color, there is red, there is green, there is blue. Those percentages are if you express like HSV values, like in CSS, for example, you can say like, OK, give me 90 degrees, you'll get that particular shade of green. This turns out to be a little bit not optimal for human perception of color. You know, like we were all taught in school, like it's all about red, yellow, and blue, right? You see some awesome flame wars online about like, these are the real primary colors. No, it's red, green, and blue. You idiots have been lied to all your lives. But if you think about the colors of the rainbow, like red, orange, yellow, green, blue, and purple, right? Like by the time we get to green, it's like, okay, maybe we should spread that out a little bit, So this is a different color space. It's red, yellow, and blue as the primary colors. And then the secondary colors derive from that. This is sort of more like how humans would perceive color, I would say. And yeah, in terms of where the rainbow colors are, they're perfectly evenly spaced here. Yeah, so if, of course, I think everyone sees where this is going, we can take those colors and map them to notes. Yeah, I had a late night. So this basic idea that you can map colors to notes, sort of done by Newton, updated to maybe a modern, more precise way of looking at it, this is a mapping that you can do. And probably just about everyone's seen some kind of a kid's toy that looks like this, right? And wondered like, I wonder how they chose those colors. And that's pretty much the story of it. There's a fairly standardized way of doing these colors. You can even buy stickers. It's kind of expensive for just like some stickers, but I'm sure they're high quality and stuff. And of course, you can stick them on your piano. This is actually my piano at home. And I got 2 kids. They're 6-year-olds. They're twins. And they really wanted to learn to play piano. But yeah, sheet music is tough, right? So I basically said, OK, I get them these stickers, and I'm going to be able to go online, and I find a whole bunch of music that they could play that like they just have these colors. It's going to be great. And then I hit like this problem that actually finding music online that's in this color scheme is really, really hard. You can have like plugins for sheet music generation software that'll apply the colors, but like I just wanted something really, really simple for my kids, right? Like they already know how Twinkle, Twinkle, Little Star goes in their head, but they just want to know what buttons to press to get there, right? Yeah, so how does it always start, right? You got an itch to scratch, you scratch it. I said, OK, I just want to I want to do like Bruder Jakob, or I want like Twinkle, Twinkle, Little Star. What can I do about that? I think I could maybe make an SVG and print that. I'm just going to do some HTML. I know HTML. It's easy. Let's do some HTML. So I whacked together a Python script, like the stupidest, simplest thing you could imagine, like opening a template, and then when it gets to the marker in the template of where the note should go, write the notes in. Like a super simple HTML page, assigning the colors for each of the notes using CSS. Pretty simple. You feed it with something that looks like this, Twinkle, Twinkle, Little Star. And the result is that you get a kid playing the piano. This is the only photo I could find of the original super first version of Chromatic when it still looked like that. And what can I say? It works. My first beta tester was pleased with the results. Yeah, so I did this in Python, but it's generating HTML. There's this language that you can put inside of HTML that can modify the HTML. I don't know if you guys have heard about that. Called JavaScript. And maybe at some point it would be cool if other people could use this, because this frustration of where do I get the music? Maybe other people also had that. But life got busy. I got a job, and then I was on rotation, and then I'm doing too much in that, and I have to also work on the original stuff that I'm supposed to work on. And yeah, I'm just being my hacker self and doing stuff on GitHub all day long, because that's what you do, right? It's who doesn't use GitHub? Come on. I went to FOSDEM 2025. There was a talk there, a keynote I went to. It's a bit of a funny story. Bradley, if you know him, from the Software Freedom Conservancy, he was there at the conference. He's totally masked up. He's avoiding everyone, testing every day. Turns out he's the guy at the conference that gets COVID. So he was supposed to give this talk, and instead Karen in Denver gave it from the Software Freedom Conservancy. I don't know Denver that well, but I got to say Bradley and Karen, they're kind of my moral heroes. They always remind me of the importance of free software. It was a really good talk. It had a really short and punchy title. Yeah, but you know what? It was a great talk. Go and watch the video. It's online on the FOSDEM website. Just Google repeating bad history, Bradley, Karen, whatever. Yeah, and of course, support the Software Freedom Conservancy. They're doing good work. Basically, the TLDR of the talk is that we all use GitHub, but GitHub is proprietary software. And they talked about SourceForge And hey, everyone remember what happened with SourceForge? That was really good for all of us, right? We're going to get burned. We always get burned. Let's not get burned, right? So I started thinking, like, maybe we should use Forĝejo. I thought about it in context of the Cockpit project. I brought it up in a meeting. I was like, yeah, guys, like, maybe we could do this. I wasn't totally serious because, like, oh my God, what a huge undertaking. But it got a little bit of traction, so I started looking into it. And I also decided on the train ride home, after being at FOSDEM, that maybe it was time to like turn Chromatic into a little bit more of a project. And just to test the waters, I'm going to host that on Forĝejo. And that's also when I decided to name it Chromatic, which, of course, the chromatic scale is all 12 of these notes. And chromatic being related to color, it was sort of an obvious name. Then I found out that 1 million people have named things Chromatic. It's not a good name, but whatever. Yeah, so people get confused about this. Forĝejo is a piece of software. It lets you run like a GitHub-like site or like GitLab or whatever. Codeberg is a particular instance that's running Forĝejo. And just to close the loop, Forĝejo itself is developed on Codeberg. So if you're going to like whatever, you would go to codeberg.org, and then they're running Forĝejo. And of course, you can host your own, which is the whole point of this stuff. It looks kind of like familiar. Probably, people who use GitHub would not be totally lost here. And in fact, that's kind of one of their things. Instead of going their own direction and doing something totally different, they say, OK, we know like where the user base is, and we want to get those users, so we're going to try and be like GitHub. So the UI is like familiar to GitHub users. The REST API, they try and be as compatible as possible. Will never be 100%, of course. And even the workflows that they have like .forgejo/workflows/whatever.yml that looks very, very suspiciously familiar to anyone who's written a GitHub workflow. And again, is not 100% compatible, can never be 100% compatible, but it's the kind of thing that when you're moving your project over, it really reduces friction. They also have migrations from GitHub. You can pull in all your issues and milestones and labels and all of that stuff. I tried this on one of our smaller projects in Cockpit. It took a while to run, but once it was done, the result was pretty good, like including like mapping GitHub usernames to equivalent Forĝejo usernames and everything on Codeberg. I was pretty impressed with how well that went. You can do SHA-256 repositories, which is like, SHA-256 object support in GitHub. Like, when's it coming? Git supports this great. It's GitHub that's really blocking that. And I don't know why they're not doing it. But a cool side effect of that is that you can create a project in SHA-256 and put it on a Forĝejo instance, and no one will ever be able to import it into GitHub. Haha. It's got static page hosting, which is where Chromatic is. I mean, Chromatic itself is just a static website. It's a dumb HTML file and then a little bit of JavaScript. I show it in a bit. And you can do branches. I think this feature is really cool. When you're working on a fork or you want to just like see how the branch changes the look of the page, and you just put like @branch name at the end. That's nice. Federation. So I asked a question in Bradley and Karen's talk. Is like, but everyone's on GitHub. Come on, like if I do my own Forĝejo and Fedora has theirs, and then there's Codeberg, and like I need to create like 27 user accounts. The answer is they're working on it. They realize that this is a huge blocker to adoption, and they're working on it. They have like some initial steps, like you can star repositories across things. Of course, this also leads to the question of moderation and banning and like all of these bad things. It's a work in progress. Yeah, CI runners. Of course, this is the hook that GitHub, like, hey, GitHub Actions, have free runners. It's great. Take the candy. You're going to be happy. Codeberg also has this. You have to like manually apply to it so they know you're not like mining Bitcoin or whatever. And the instances are kind of small. I mentioned that they also have workflows that are compatible. Annoyingly enough, if you want to use workflows, you have to do your own runners. But they have this thing called Woodpecker CI, and you can use their runners for that. It is just another YML thing. It's you can kind of understand what's going on by looking at that. Yeah, so maybe back to Chromatic. How does it look? This is basically the website. I'm not a designer. I know people who are designers, but I'm definitely not a designer. Yeah, it's the simplest stupid thing you could think of. It's got some nice features, like you can create a link. So if you do like your own song and you click the create link button, then you can send that to your friends, which is nice. There's an open issue that I think Sylvia was going to work on at some point, that like compiling a list of these links for like common children's songs. Maybe. Yeah. I like PRs. Printing, when you print it, like basically I set like some CSS stuff, that entire top thing disappears. So when you print it, it looks like this, which is pretty much what you want. And yeah, as I said, I love PRs. So if anybody wants to contribute to this project, I would really, really appreciate contributions. Yeah, and other than that, thank you very much for coming.
Do you already have a place where people can like contribute their own to Chromatic translated songs, so you can share them with like?
No, I don't, and I have an open issue, and I'm waiting for a pull request to like basically create this page. And then that would also be kind of cool because like once the page is created and like has a couple of songs, then obviously the process of adding some extra songs, that's like really good, easy PR fodder for would-be contributors.
Sorry, totally not a Chromatic question, but for the federation of Forĝejo instances, I mean, there is 2 existing things out there, like Matrix and the whole Fediverse, like with Mastodon and so on. I mean, that seems like a good thing to integrate with, so that you have shared accounts which already exist, and you have these existing web of networks of people.
Yeah, there's actually like a million things out there, right? Because like Blue Sky is trying to do this thing, and there's this like @protocol stuff, and there's this Nostr, and like there's a million people trying to do this like federated thing, while also trying to solve the moderation problem, right? From what I understand, they're sort of going closer to the Mastodon line. Like they have this activity pub thing. Yeah, I don't know too much about that, but yes, I think they are obviously aware of that. I did some very cursory research. They have an open issue, and like they have like a document which is like the features they want to do, and every feature is like, we will do this work because it will be a user visible change. And our idea is to do like very incremental. Like I think they're working on getting mentions across instances working now. And of course the dream is like I can fork your repository onto my different instance, do a PR there and propose it back over. Like that would be the big one, right? I can kind of like show if there's, I mean, are there?
Yep, we have one on.
Sorry, yeah.
So I guess this is pretty obvious, but I think if we want MIDI support, for example, we would have to add a PR, I guess. Or
oh, yeah, I forgot to talk about that. No, there is MIDI support.
Does it? Nice. Oh, yeah, it does. Yes, let's go.
Yeah, thank you for asking. I totally blanked on mentioning that. This is great. So basically what I do, like if I want to like figure out some new German kids song for my kids line, I'm from Canada, but I live in Germany, and my kids want to learn German kids songs. I'm not familiar with them. I can find sheet music for them easy enough. I plug my laptop into my piano using a USB cable. I click on this button, and then I can just start playing, and it'll start writing, which is kind of fun. Yeah, you know, if you want to do like, you can like imagine how this works. It's the simplest possible thing. Whatever. You just write like in the very obvious form, and you basically get that out of there. You can also do like sharps or like flats. Whoops, flats. Yeah, and then obviously when you're playing MIDI in, this may be a little bit confusing. Again, I'm not a designer. I only know designers. What this does, if it's not totally clear, is when you play the black key on the piano, should that be written here as a sharp or a flat? And that like lets you decide which one it'll land as when you play it in. Yeah.
How do you envision to handle multiple octaves? Like, this is just
right. So the way of handling multiple octaves is that you add this character, and it actually maps that to like a nicer Unicode equivalent. And you can do up to 3 of those, and there's a Unicode character for that as well. So you put it in as apostrophes, but it converts it to this like, and then it's the same for commas if you want to go down. Yeah, and you know, usually you'll see a song that like has at least a high C in it, and that's generally what you use. My kids kind of understand that by now. I mean, mostly they understand like normally the song will kind of flow in a way that it would lead them to know that they would be playing up there anyway. And yeah, obviously there's no timing information here, but if you already know the song and you just want to know kind of what buttons to press, it turns out to be almost exactly what you want.
Does it handle the, I think, German notation when there's H instead of B?
No, it doesn't. We were talking about this yesterday and like trying to figure out like why Germans are saying H instead of B. That's a whole other thing. I almost put it in the music theory section. I took a pass on that. It's a very valid question though. Like probably it should handle H. You should file a PR for that.
It's not a question. It is, given the age of German, there's also other countries that do do, re, mi, fa, sol, la, si, do.
Yeah, I know someone from one of those countries. And I've had this comment before. PR is welcome. If we can figure out a way to make it work, then I would be really happy to see that PR as well. I forgot to take a selfie with y'all. I'd like. Everyone smile. Any other questions?
Note duration?
Yeah, come on. Like this is that thing like no timing information. The kids already know like how the.
What are your kids asking for? Because if you ask people like parents what they want to have for their kids, kind of weird. But what are kids asking? Like if you ask your kids what's missing, what are they saying?
Repeat question? Yeah, so what are the kids asking about what's missing? Normally they're just asking for like, Mama, I want to play like Auf die Straße hoch und nieder. And then I, figure out how to play that and then give them that. They haven't really asked for features per se. That's mostly annoying behavior of adults.
Okay.
I do get that one too.
The timer for whose turn it is.
Yeah, it's like nobody's playing piano, and then like one of them sits down. No, I wanted to play piano. Okay, then why didn't you?
Okay, so thank you.
Thank you.